Hola clase. Today we are going to learn how to tackle problems that involve using multiple properties. And as usual, I will give you a how-to step by step, and then we'll make an example together. Now, before you tackle any of these things, you need to know pretty much all of your angle properties. So your angle properties by themselves, and I'm talking about angles at a line, angles at a circumference, all of those ones. The properties of angles in polygons, so angles inside a triangle and isosceles triangles. Now, the properties of angles in parallel lines. So remember, you only have three options, either alternate or corresponding or co-interior angles, and you need to know the properties of all that. And then angles in circles and circumferences, and that includes, of course, cyclical, quadrilaterals, and all of the ones. So you need to know all of that, and that's just memory. You study them until you know. Now, how to tackle one of these things? First, you always try to identify what you want, because if I don't know what I'm searching for, I don't know if I'm finished. And the especially important thing is that you realize if you're searching for an angle or for a length. Because if you're searching for a length, then you're going to need to use Pythagoras or trigonometry. The only two ways, apart of similar triangles, to get lengths. Well, then you're going to, in your diagram, label everything of known value. And remember, known value does not need to be a number. It needs to be something that you know the value by a property or because it's equal to something else. And then you're going to link these two things using the adequate property. And that's why you need to know them all, because you don't know which one you're going to need. Probably it's going to be more than one. So remember, this is the process in which you always ask yourself, well, what do I need? And do I have all the pieces? And ideally, the answer would be a yes. Most of the cases, it's going to be a no. If it's a no, then you're going to have to repeat the whole process. Ask yourself again, what do I need? Do I've got all the pieces? And you're going to repeat as many times as you need until you only have yeses. You have all the pieces. That allows you to work backwards until you get to whatever it is that you need. Now we're going to see this in an example. This is from a past exam. So I am putting it here, and you can pause the video and have a look by yourself. Okay, they give me this exercise, and in this case, my objective is actually to make a proof. They want me to prove that these triangles SAG, AHG, and ABG are equal. Now, the first step is to identify in the diagram what I want. They label them for us. So this angle here is SAG. This angle here is GHA or AHG. So let's make tiny arrows if we need. So this one here is the AHG. This one here is AAG. and then this third P in here is the third one, which is from A to B to G. And I need to prove that these three angles are equal to that value P. So I've been thinking of what do I see in there. First of all, they tell me that this line from S to T is a tangent, and they mark an origin there. So I know there is an angle there of 90 degrees. Then I look at two angles that are starting and finishing in the same points. So they're actually going to be in the same chord. And then I realize that this line here cuts the circumference or the circle, and you're going to imagine that it cuts it in the middle because I did this by hand, but they give me this is the point of origin. So I know that then there is a triangle in a semicircle. So I know a bunch of angles that are right angles there as well. And from there, I've got a strategy in my mind. Remember, green is what I think. I haven't even started putting things on the paper. So I realize that proving that AHG and ABG are equal, that's going to be a one-step thing. I can do that. Then I'm going to have to prove that either of these it's equal to this SAG that they gave me. So I need to prove that it's equal to one of them somehow, and then I will be sorted. And for that, I'm going to use the semicircle property that I see here in that side of the triangle. And I also know that angles in triangle add to 180. So I will always be able to grab it from there. Okay, now that I've thought about what do I need to do, remember, green is what I think, then I can actually start getting my points and putting things on the paper. So I'm going to start from the easy one. So I can come here and just claim that the angle GHA and the angle GBA are equal. Now I need to justify it. So this is true because angles from the same chord or in the same chord are equal. And remember, I need to know the rules to be able to use them. Then I can come and begin working to prove that any of these two is equal to the third one. So I'm going to use here the angle HAT that we said it was 90 degrees. And that is because angle between the tangent and the radius equals 90 degrees. And remember, I don't need to write the whole thing. Let's take this one out, but it needs to be understandable enough. Of course, if that one is 90 degrees, the other one, it's also an angle between tangent and radius. I can put it there, save myself a line of writing. At the same time, that angle that we identify as 90 degrees, let's call this one alpha, so we know which one is it in the diagram. And let's call this one beta, so we know which one it's in the diagram as well. So that angle, it's also 90 degrees, but for a different reason. This is because angles in a semicircle are 90 degrees. Okay, now that I've got these two, I can begin trying to link it to the third angle. So I know that angles or interior angles, to actually be proper, in a triangle, add to 180. So using, let's use colors so you see which angle we're talking about. Using this triangle, from which we know one of the angles, I can come here and say that 180 needs to be the same as GAH plus AHG plus 90. That leaves me with this GHA plus AHG being equal to 90. I just took this 90 and passed it subtracting here. All right. I need to link it to, remember, keep track of your objective, to this angle from S to A to G. So because I said that the angle from S to A to H was 90 degrees, that's the same as the sum of two angles. The one that I want, SAG, plus the extra one in the 90 degrees from G to A to H. Now, if these two things are true, let's call it 1 and 2. Remember, if I'm going to mix things, I'm always going to label things so the person reading can follow. Now, both those two things are equal to 90 degrees, which means that they are equal to each other. So this sum of angles, that's number 2, equals this sum of angles from number 1. Now in here, I've got the same angle in both sides. So this is going to cancel. To break manipulation, if you pass it, it's going to subtract. And that leaves you with this angle SAG being equal to this angle AHG. Now that is a good thing because you already proved here that that angle was the same as the third one in action. So now I can come here and link all of it to give the final answer. So yes, SAG equals to, let's put it in the same order that they give it to me, AHG, which equals ABG. And all of that equals that P value that they gave me. So now I can prove that I demonstrated using algebra. So we boxed it, QED, and we're done. Okay, so now it's your turn to go there and practice. Thanks for watching.